In this lesson, we're going to learn how to simplify radicals. When finding the square root of a number, what we're asking is what number multiplied by itself is equal to the number inside the square root sign. So for example, the square root of 16, we're asking ourselves what number times itself is equal to 16. And so we get that it's 4 times 4, I'm not sure what that sign is, 4 times 4, and that means that the square root of 16 is 4. So we say the square root of 25. We would say that that's equal to 5 because 5 times 5 is 25. The square root of 64 is equal to 8 because 8 times 8 is 64. And so we're going to start by doing that, and we're going to start by doing prime factorization. And so if you remember from factor trees from earlier in your life, factor trees are where you took a number and you broke it down into prime factors. So 45, you can start with saying that's 3 times 15 or 5 times 9. What is not helpful is to say 1 times 45. Don't do that because it doesn't help. So if I say 5 times 9, then those are two factors. What I'm looking for is I'm looking for each of them to be a prime number. Now 5 is a prime number, 9 is not a prime number, so I'm going to keep going on 9. So 9 is 3 times 3. Now if I look at those numbers, 5 and 3, those are all prime numbers. So 45 is equal to 5 times 3 times 3. Sometimes people wonder, what if I thought of something else? What if I did, say, 3 times 15 for 45? Will I get a different answer? The answer is no. You're going to get exactly the same thing. 3 is prime, so we're going to break down 15 to 3 times 5, and you notice you still get 3 times 3 times 5. It doesn't matter what order you write it in. Usually when we write prime factorization, we go from smallest to biggest, but it truly doesn't matter because multiplication is commutative. Okay, let's try number 2, 56. So think of your times tables. You know that 56 is 8 times 7. 7 is prime, 8 is not. So 8 is 2 times 4. 2 is prime, 4 is not. So 4 is 2 times 2. So go back and look at all your little leaves, is what I like to call them on factor trees. And you have 2 times 2 times 2 times 7. It is helpful to group all of the same numbers together, and you'll see why that's helpful in a minute. But put all the 2's together and then the 7. Okay, go ahead and try number 3 and 4. Just break those down into prime factors and then start the video again. It is very helpful for you, and I encourage you to do this without a calculator as much as possible. So something like 240, recognize that it's divisible by 10, and so you can just break down to 24 times 10, and then with your knowledge of times tables, you should be able to do almost all of these without much help from your calculator at all. And that's going to be something that's consistently true. If you can just break down with a couple small little things, you'll be able to go through without a calculator to do most of them. And the reason that that's good is, number one, it helps your brain work out, but also it helps you save a lot of time so you're not putting in small facts into the calculator. So for 240, I have 2 times 2 times 2 times 2 times 3 times 5. That's the same thing as saying 2 to the 4th power times 3 times 5, but for our purposes, this is going to be more helpful. Okay, and then the last one was 550. So again, I recognize that it's divisible by 10. 10 is 2 times 5. 55 is 5 times 11, and now I have all prime, so 2 times 5 times 5 times 11. Okay, the main idea of what we're doing today is simplifying a radical expression, and so there are some rules that we have to follow when we simplify a radical. So for a radical to be truly simplified, there can be no perfect squares in the radicand. The radicand, by the way, that's the number underneath the radical. So if you have like square root 2, 2 is the radicand. So no perfect squares. So for example, when I say the square root of 4, 4 is a perfect square number, so that would not be a simplified answer. Also, if you had square root 12, that's not simplified because 4 goes into 12, and 4 is a perfectly square number. So that's one thing you have to watch out for. Rule number 2 is you can't have any fractions in your radicand. If you have a fraction in the radicand, then it's not simplified. And rule number 3 is no radical in the denominator. So if you have a fraction, you cannot have a radical in the denominator. Now we'll see as we move on through math that there are some times where we're going to not really worry too much about some of those things, but for right now we are going to concentrate on all 3 of those rules. Okay, number 5, to simplify a radical expression, so square root of 54. Now what we're not going to do is type it in our calculator and get a decimal because that's not an exact answer. We are looking for exact answers. And so here's the way you do it. You start by taking 54 and break it down into its prime factors. So 54 is 9 times 6, and 9 is 3 times 3, and 6 is 3 times 2. And so I'm going to rewrite square root of 54 as the square root of 2 times 3 times 3 times 3. So those two are equal expressions. Now what I do is under the square root, when you have a square root symbol, it's a radical, but it's a square root because there's a little 2. We don't usually write the 2 in there, but it's a square root because there's a 2 in there. Now, it's also true that you could have a cube root, and so in a cube root, there would be a little 3 in there, and you would write it. So if we don't see a number written in the little crook of that radical symbol, then we know that it's a square root. But the 2 right there reminds us that we're looking for perfect squares, and so in order for something to be a perfect square, there has to be 2 of them. And so what we're going to do is we're going to look for pairs under my radical. And so I see right here I have a pair of 3's. Now, it doesn't matter if you do that pair of 3's or this pair of 3's. It doesn't matter, but just you get a pair of 3's. Now, I kind of have a little analogy that I use, and so the analogy is kind of odd, but it really helps remember how things work. And so let's look at this radical symbol as a prison camp. And so in the prison camp, we have these prisoners. Their names are 2, 3, 3, and 3. And so the good news is that there are ways to escape this prison camp, but in order to escape, you have to have a twin. And so you and your twin can try to escape. So the 3's, these two, they can go together. The 2 and the 3 that are left behind, they're just stuck. They're going to have to stay. But when the 3's escape, what always happens, sadly enough, is one of them dies. So 3 is the only one that makes it out. And then you've got the square root of 2 times 3 left inside, and so it's just going to be 3 squared root of 6. That is the same exact thing as square root of 54, but it is simplified. So even though the prison camp is kind of a sad scenario, it does help because it just kind of helps you think about the way to do something like that. So with 12, let's do number 6. Square root of 12 is 3 times 4. And so 4 is 2 times 2. So the square root of 12 is 3 times 2 times 2. Do you see a pair of anything? We see a pair of 2's. They're going to come out. And so the 2 comes out, one of them dies, and you've got 2 square root of 3. And that's your answer. That's your simplified radical. Sometimes people wonder, well, why does one of them always die? What it is what you've got the square root of 2 times 2, that's the square root of 4. And the square root of 4 is 2. And so when you bring out a pair, you're just saying that because there's 2 of them, when you take the square root, it's just the 1. So you can think about that. Number 8, it's the square root of 21, and so 21 is 3 times 7. And you put that under a radical, 3 times 7, there's no pairs of anything. So there's nothing you can do to simplify that. So number 8 is actually already simplified. So you can just write equals square root 21. Okay, number 9, square root of 108. So this is a times tables number. So 9 times 12. And 9 is 3 times 3. And 12 is 3 times 4, and 4 is 2 times 2. And so what we can do is we can write square root of 3 times 3 times 3 times 2 times 2. Now here I see a pair of 3's, and they can come out. So I'm going to put that out there. One of them dies, of course, because it's really the square root of 9, which is 3, and that's why we say one of them dies. And then the other one is 2 times 2, and so that comes out on one of those. So when I have 3 and 2 outside, they're going to be multiplied together, and then whatever's inside. So I have 3 times 2 is 6, square root 3, and that's the answer to number 9. That's the simplified radical. And so what we do in math is we use radicals a lot, and so we need to simplify them so that somebody's not writing square root 108 and somebody else isn't writing 6 square root 3. We all will write 6 square root 3. And so we know how to do that. Okay, now we're going to go back to number 7 just because the way it was laid out on the paper, I put these on here differently. So number 7 is square root of 48, and so that's either 3 times 16 or 4 times 12 or 6 times 8. It doesn't matter which of those you use actually. So if I did like 3 times 16, I could say 16 is 4 times 4, or I could say 2 times 8. 4 times 4 is 2 times 2. And so I'm going to have the square root of 3 times 2 times 2 times 2 times 2. Now, alternatively, you could say, well, what if I say that that's 6 times 8? Perfectly fine. You're going to have 3 times 2 and 4 times 2 and 2 times 2 there. So you have 3 times 2 times 2 times 2 times 2. So exactly the same thing. And then you look for pairs. You have a pair of 2's and you have another pair of 2's. And so 2 comes out, the other 2 comes out, and you're left with 4 square root 3. Now let me show you something that is really helpful as you start to do this a lot more. Back when I did 48 was 3 times 16, that's a really common one, by the way, it's good to remember. But if you see that it's 3 times 16, you already know that 16 is a square number. So it's basically the square root of 3 times 16, you know, is 4 times 4. And so you could just stop with that and take out a pair of 4's and you have 4 square root 3. So that's one thing you could do. If you recognize a square number inside, you can just go ahead and take that out. You don't have to break down the 4's into 2's. Okay, now number 10 is the square root of 306. That's not one on our times tables, but I'm going to start with something like as easy as I can see it's divisible by 6 because 6 goes into 30 5 times and it goes in there 1 time. So it's going to be 6 times 51. Now, if you didn't know that, or you didn't really know how to figure that out, you can use your calculator to break it down into that initial number, but after that, try to do it without. 6 is 2 times 3, and 51, this is another good one to just know, it's 3 times 17. And as you become more familiar with a lot of these numbers, you'll start to recognize them and say, oh yeah, that's 3 times 17, and so that's good to know. So I'm going to take out my pair of 3's, and so 3 square root inside, I've got 2 times 17. Oops, which is 34. And so the square root of 306 is equal to 3 square root 34. Okay, I want you to pause the video and I want you to work on 11 and 12 and then start the video when you're done and see what you come up with there. 324, you might have recognized that as a square number. Maybe you didn't, but it's 18 times 18. And so one thing you could do if you knew your square numbers, you could just say, oh, well, that's the square root of 18 times 18, so the answer is just 18, because 324 was a perfectly square number, so it's just 18. Now what if you didn't know that? If you didn't know it was a square number and you start with something like, well, I can see that it's divisible by 4 because 4 goes into 32 and it goes into 4, so it's divisible by 4. So it goes into 4 81 times, and 81 is 9 times 9, and 4 is 2 times 2, and 9 is 3 times 3, and this 9 is 3 times 3. There's a lot of ways along there that you could have stopped and said, oh, well, 4 is a square number and 81 is a square number. So let me just break it down to the bare bottom here. You can take out a pair of 2's, you can take out a pair of 3's, another pair of 3's. There's nothing left inside my prison count, so there's no need for a prison count. 2 times 3 is 6, and 6 times 3 is 18, and so that's my answer. Now, like I said, you could have stopped a lot of places along the way. You could have stopped when you said, oh, it's 4 times 81, and you recognize both of those as square numbers. So what you have is you have the square root of 4 times the square root of 81. You know what the square root of 4 is, and you know what the square root of 81 is. So that's equal to 2 times 9, which is 18. So there's a couple ways you can look at it, but there's only one answer, and that's 18. Number 12, 600 is 6 times 100. 100 is 10 times 10. I'm going to stop right there because I can say 6, well, okay, 6 is 2 times 3, and so I know that that's not going to have any pairs of anything that are going to come out. So I'm just going to put them back together into a 6. And then 10 times 10, I take out a pair of 10's, so 10 square root 6 is my answer for number 12. Okay, last is number 13, and 255, if it ends in a 5, you know 5 goes into it. So 5 goes into 255, goes into 25 5 times, and goes to 5 1 time. There's that 51 again. Remember I told you that that's a good number to remember? So this is the square root of 5 times 3 times 17. Those are all prime numbers. There are no pairs. There's nothing I can do. There's nothing that can escape my prison camp. So I'm just going to put it all back together and say that that already is simplified. Square root of 255 is the square root of 255, and there's nothing else I can do about that. Okay, now the next few problems we see, we have some variables. The variables are going to work exactly the same way. So for number 14, the square root of 64a squared, I'm going to break down 64. 64 is 8 times 8. I'm just going to leave it at that. And a squared is a times a. So look for pairs. I have a pair of 8's, and I have a pair of a's. There's no more prison camp. There's no more square root. There's nothing under it. So the square root of 64a squared is 8a. Okay, go ahead and pause the video and try 15 and 16. Okay, 15. Concentrate on the 108, 9 times 12. So 9 is 3 times 3. 12 is 3 times 4. And so one thing that you will see that I'm starting to do is, and you can start to do this too, is you don't have to actually make a factor tree. You can break these numbers down as you go. So as I said, 9 times 12, and I start to break that down. So I'm looking for a pair, and I see a pair of 3s. I see a pair of 2s. I see a pair of B's, and I see another pair of B's. What's left is just that 3. So 3 times 2 is 6, B squared, square root 3. And that is my simplified version of square root 108, b to the 4th. And then 132, if I know my times tables, that is 11 times 12. So 11, 12 is 3 times 4. And then a to the 5th is written out like this. So looking for pairs, I see a pair of 2s, a pair of a's, and another pair of a's. So I'm going to have 2a, a. Under my radical, I'll have 11 times 3 times a. So when I write that, I'm going to have 2a squared and then square root 33a. Okay, now with 17 and 18 and 19, we have multiple variables. Good news is it works exactly the same way. So I'll do the first one with you, and then you're going to try the next two. So 17, 18 is 2 times 9, and a to the 2nd, b to the 5th. Now look for pairs. I've got a pair of 3s, I've got a pair of a's, I've got a pair of b's, another pair of b's. What's left under my radical is 2b. So simplify this part of it, 3ab squared times square root 2b. And that's the simplified version of square root 18a squared b to the 5th. So pause the video, do 18 and 19. Let me show you one thing I did with 512. I broke it down, and I did use the calculator on this, to 8 times 64. I recognize 64 as a square number, so I'm going to leave that as 8 times 8. The other 8, though, I broke it down because I was looking for pairs and I knew that I'd find some 2's in there. So I'm going to write it as 2 times 2 times 2. That's the 8. And then 64 is 8 times 8. So that's how I'm going to write that. And then a to the 6th, I'm going to kind of squeeze that in here. And then b to the 3rd, and then c to the 5th. And I look for pairs. I see a pair of 2's. I see a pair of 8's. I see a pair of a's, another one, and another one. So I see a times a times a. I see a pair of b's. I see a pair of c's and another pair of c's. Underneath my radical, I still have 2, a b, and a c. So when I simplify that whole thing, I'm going to have 16 a to the 3rd, b, c to the 2nd, square root 2bc. On number 19, I see easily that it's divisible by 5. So I'm going to figure out how many times 5 goes in. And you can use a calculator for that if you need to. 105 is also divisible by 5. So what I've got as far as just the number part of it, I've got 5 times 5 times 3 times 7. And that takes care of all my numbers. One of the common mistakes people make here is they skip something. They miss one of their little leaves of their factor tree. And so it's a good idea if you're doing a factor tree to circle those little leaves. Do something, just make sure that you're really getting the number that you need. And then x to the 3rd, and then y to the 6th. Writing out exponents the long way, that's a really good strategy to help you make sure that you're not missing anything along the way. And we'll talk a lot more about that as we talk more about exponents later on. So my simplified answer is that. Okay, the next thing that we're going to do is we're going to do some operations with radicals, and operations are things like add, subtract, multiply, and divide. Multiplying is the easiest one, so we're going to start with that. So when you multiply, we've got these examples up here that I've got for you. So example number 2, it says the square root of 5 times the square root of 15 is the same thing as the square root of 5 under 50, or 5 times 15. So what I'm trying to point out there is you can write them separately or together, whichever one suits your purpose. And so depending on what you're doing, you might find that it's easier to do one or another. And then example 3 is going the other way around with that. The 2 square root 5 and the square root 15, the 2 will stay outside. So whatever's outside the radical will stay outside. So number 20, there's a couple ways that we can approach that. The negative is outside, so you've got this negative 1 outside, and then we've got square root of 12 times 24. Now you might be tempted to get your calculator and find out what 12 times 24 is, but that's really counterproductive. It will just make more steps for you. So what you should do instead is, instead of writing 12 times 24, break it down. What is 12? It's 3 times 4. And what is 24? 24 is 8 times 3. So now what you've got is you've got your radical with all of your numbers written out as prime factors, so you can start going for a pair. So I see a pair of 2's, another pair of 2's, and oh hey, a pair of 3's right there. So what I'm going to have is I'm going to have my negative 1 is outside. These 2's will join it. These 2's will also join. And my 3's, right there, they'll join as well. What do I have left inside my radical? I just have this 2. So simplify what's outside. 2 times 2 times 3 is 12 times negative 1. And that is your simplified product. Okay, number 21, square root of 20 times square root of 5. This one, if you happen to know what 20 times 5 is, it's the square root of 100, and the square root of 100 is just 10. And so if you know that, that becomes easier that way. However, if you don't happen to notice that, you could do square root of 20 is 4 times 5, and then times square root of 5, so you have another 5 under the radical, so you have a pair of 2's and a pair of 5's, nothing left underneath. And so that's equal to 10. Okay, pause the video and do 23 and 24. For 23, square root of 12 times square root of 12 is the square root of 12 times 12, and you see a pair of 12's. Now that's a really good thing to notice, because if you have a square root of 12 times square root of 12, basically you have a square root symbol that's squared, and that basically cancels it out. So square root of 3 times square root of 3 is 3. Square root of 5 times square root of 5 is 5. Square root of 12 times square root of 12 is just 12. And so that's something that we're going to see a lot. On number 24, kind of the same idea. You've got a negative, and that's still outside, but then you've got square root of 5 times square root of 5. So if you want to look at it as square root of 25, then you've got negative, and square root of 25 is 5. Or you could write it like this. Say square root of 5 times 5, and take out a pair of 5's. So either way you look at it, there are some ways that you'll see are a little bit easier as we keep having more experience with this. But that's how you multiply radicals. And so multiplying radicals, we're going to do that a lot, and it's really the easiest operation. The next one we're going to do is adding and subtracting. So going back to remembering when we added like terms, when you have variables and stuff, you have to have like terms. Radicals are the same way. If you have the square root of 3 plus the square root of 3 plus the square root of 5, you can add the square root of 3's. You have 2 of them. But then the square root of 5, you can't do anything with that. So the answer would just be 2 square root of 3 plus square root of 5. So I've got example 5 and example 6 for you to look at as well. So example 5, 2 square root of 3 and 3 square root of 3. That altogether, since the square root of 3's are the same, I've got 5 square root of 3. So as long as the radicands are the same, then you can add or subtract. If they are not the same, then it's like adding an x plus a y. You can't do anything with that. So let's take a look at some of these examples. So number 26, I've got square root of 10, and by the way, that's 1 square root of 10, plus 3 square roots of 10. So it's kind of like if I have 1x plus 3x, I have 4x. So if I have 1 square root of 10 plus 3 square root of 10, I've got 4 square root of 10. Now that's all you have to do. As long as the square root of 10 can't be simplified, which it can't, then we're done. So 27, you look at that one, square root of 20 minus square root of 5, those radicands are not the same. So you might say, oh, well, you can't do anything and we're done. But actually, the square root of 20 can be simplified. So square root of 20 is 4 times 5, and so I can simplify that. So it's 2 square root of 5. That's the square root of 20. And then minus the square root of 5. So if I've got 2 square roots of 5 minus 1 square root of 5, I have square root of 5. One thing you cannot do is you cannot say square root of 20 minus 5. This does not work the same way that multiplication works. That's wrong. Okay, pause the video and see if you're able to do number 28. I'll give you a hint. You want to simplify both of those radicals before you do the subtraction. Okay, what you should have done for 72, 72 is 8 times 9, so I'm going to write that as 8 times 9. And I'm going to simplify by taking out a pair of 2's and a pair of 3's. So 2 times 3, that's 6, and then square root 2 is left underneath. That's what square root 72 is. For 18, that's 2 times 9. So I'm going to take out a pair of 3's, and so I'm going to have 3 square root 2. So what this problem is saying is it's saying 6 square root 2 minus 3 square root 2, and since my radicands are the same, I can do that. So 6 minus 3 is 3 square root 2. Again, it's like if you have 6x minus 3x, it's 3x. So that's how you would do that one. For the last part of this lesson, we're going to talk about dividing, and dividing is probably the hardest operation with radicals. So if you look at the examples that I've got in the box, example 7, 8, 9, and 10, so let's just focus on those. So look at example 7. It says the square root of 25 divided by 20. So what I did first was I simplified 25 over 20. Just simplify the fraction. 5 goes into 25 5 times, and it goes into 24 times, and that's where I get the 5/4. So then what you do is you can separate that into two separate radicals, the square root of 5 over square root of 4. And I know what the square root of 4 is. It's just 2. And so that's how I get that answer. That works out really nice because I've simplified my numerator. There's no square numbers underneath my radical. Square root of 5 is as good as you can get. And there's no radical in my denominator because that's against one of the simplifying rules if you remember that from later. Okay, let's look at example 8. Example 8, I've got square root of 64 divided by 25. So 64 and 25, I recognize both of those as square numbers. One of the reasons I have you memorize all the square numbers is that it helps a lot in speeding things up because you recognize that's a square number. Square root of 64, I'm going to write that on the top, and then square root of 25, I write that on the bottom. And so now, since they're both square numbers, it's just 8 over 5. Okay, now, it doesn't always work that way, obviously. So if you look at example 9, square root of 72 over 98, if I was to separate them, they're not both square numbers. But look at how it works out. I've got the square root of 36 times 2, that's 72. 98 is 49 times 2, so separating them works sometimes, and sometimes you want to keep them together like that. You just have to kind of play with the numbers and see. But 36 times 2, I can take out, the 36 is 6 times 6, so I can take out a pair of 6's. And on the bottom, 49 is 7 times 7, so I can take out a pair of 7's. And so I've got 6 square root of 2 over 7 square root of 2, and any number divided by itself is 1, so I'm just left with 6 over 7. And then example 10, square root of 128 over 25. Again, if you separate them, you recognize that 25 is a square number, and that's really helpful. So the square root of 128 is 64 times 2, so I simplify that down to 8 square root 2. And then the square root of 25 is just 5. And so I just leave this. This is my answer. There's no square numbers under the radical. There's no fractions under the radical. There's no radicals in the denominator. And so all of the rules are satisfied. So let's try a few examples. Number 29, square root of 72 divided by 6. The first thing I want to check is, see, does 6 go into 72 evenly? And actually it does on this one. So 72 divided by 6, that comes out to be 12. And so that's the same thing as just saying the square root of 12. And the square root of 12, that's the square root of 4 times 3. So I'm going to say, oops, hold on, 4 times 3. So then I take out a pair of 2's and I get 2 square root 3. And that's the exact same thing, but now it's simplified. So when we write radicals, we want to do it simplified. We don't want to leave them as non-simplified. Okay, let's go to 31. Square root of 18 divided by 98. So obviously 98 is not going to go into 18, so I can't do the same thing that I did in the last problem. Neither 19 or 98 is a square number, so I think I'm going to try to separate them and see what happens. So 18 is 2 times 9, and 98 is 2 times 49. And so what I have is I have a pair of 3's on the top, so 3 square root 2, and on the bottom I have 7 square root 2, and as we saw in one of the previous examples, Square root of 2 divided by square root of 2 is 1, so I'm left with 3 over 7. Okay, pause the video and you try 30 and 32. Those are over to the right on your paper. So try 30 and 32 and see if you can get them. Okay, for 30, 54 does not go into 24, and neither one's a square number or anything like that. So if that is the case, then usually what I do is I try to just write them separately. So 24, I can do 3 times 8, and 54 is 9 times 6. And so when I separate those, I'm going to get a pair of 2's, square root 6, and here I'm going to get a pair of 3's, square root 6. Now after I've shown these examples, people start to wonder, well, is it always going to work out like that? No, it's not. We're just starting with some pretty simple examples. So things should work out pretty easily for these first few examples. Number 32, square root 75, or 75 doesn't take 16 in there, but 16 is a perfectly square number. So I'm going to think about square root of 16, and that's just going to give me my 4 for my denominator. So then the square root of 75, I'm just going to break that down to 3 times 25, so 3 times 5 times 5, and so that's 5 square root 3. Now that doesn't look like a really nice answer, but it actually meets all of the qualifications to be simplified. 3 is under the radical, and it's not a square number, and it doesn't have a square number. There's no fraction in my radical, and there's no radical in the denominator, so that's my answer. Okay, the last part of the lesson, this one comes up a lot as we move higher in math, so we'll have opportunities to use this a lot in secondary too. If we have a radical in the denominator, so like if you've simplified it and you have a radical in the denominator and there's nothing you can do about it, so if you look at this, like we took square root of 18 over 27, you divide it, simplify it, and you still have square root of 2 over square root of 3. This right here is making that not simplified, so that violates that definition. So the square root of 2 is not the problem, but square root of 3 is because it's in the denominator. So what we can do is we can do what's called rationalize the denominator, so we make it into a rational number instead of an irrational number. And so we rationalize the denominator by multiplying by 1. So if you remember when we work with fractions, sometimes we'll multiply by like 2 over 2 or 3 over 3 in order to get common denominators. So if you're doing like 5/4 plus 3/8, I need common denominators. So what I do is I multiply this one by 2 over 2, and that gives me 10/8 plus 3/8, and then I can add them. So we multiply by 1 all the time already. And so what I'm going to do here is I'm going to multiply by 1, but the way my 1 shows up is going to be a lot different. So I've got right here, I'm going to take my square root of 2 over square root of 3, and I'm going to multiply by 1 in the form of square root of 3 times square root of 3. The reason why I chose that form of 1 is because look at what happens across the bottom. Square root of 3 times square root of 3 is just 3. And so now we're done because it doesn't have any problems with that. So let's look at oh, and I've got a little asterisk here. Remember, when you rationalize the denominator, you need to go back and make sure that other simplification rules are met. So there's no square numbers under the radical. There's nothing else you can simplify. So make sure that all that's been done. So let's look at number 32. So I've got square root of 25 over square root of 18. So if you separate that out, the square root of 25 is 5. That's great. Square root of 18, that's 2 times 9. So I've got the 3's that can come out. So I've got 5 on top and then 3 square root of 2. The problem there is the square root of 2. I cannot have square root of 2 on my denominator. So if I look at 5 over 3 square root of 2, in order to get rid of this problem right there, what I'm going to do is I'm going to multiply by 1. And the 1 I'm going to choose is square root of 2 over square root of 2. The reason I do that is because when I multiply across the bottom right there, this square root of 2 times the square root of 2 is going to give me a 2. On the top I'll have 5 square root of 2, and then here I've still got my 3. So I'm going to have 5 square root of 2 over 6. And that is the simplified version of my original problem. You see, the original was a problem because it had a fraction in the radical, and that's against the rules too. Okay, let's try another one, number 34. Everything is already broken down as much as it can be. I can't do anything with square root of 2. I can't do anything with square root of 5, but it's violating the simplification rule because of that square root of 5. so I need to get rid of it. So if I multiply by 1, how should I write my 1? I don't want to do 1 over 1, obviously, because that's not helpful. Do I want to do square root of 2 over square root of 2? That would get rid of the radical on the numerator, but that's not what I'm trying to do. The radical in the numerator is not the problem. The problem is this. So I'm going to multiply by square root of 5 over square root 5. So on the top, I'm going to have 2 times square root 2 times the square root of 5, and I can put those under the same radical. I learned that earlier. Over square root of 5 times square root of 5 is just 5. So my simplified answer will be 2 square root 10, there's nothing I can do with that, over 5. Now, one thing of vital importance that we recognize is you cannot cancel those numbers, because this is not a 10, it's a square root of 10, which is about 3 point something. You can't simplify that with a 5. So something inside a radical and something outside a radical cannot be canceled. So this is your final answer. That is simplified, and you are done. Okay, moving on to number 33, square root 75 over 7. So I want you to pause the video and see if you can get this one. So if we write this separately, square root of 75, that's 3 times 25. Square root of 7, I can't do anything with that, so I'm going to have on the top a pair of 5s, and then square root 3 over square root 7. The problem is the square root 7, so I'm going to multiply by 1. And on the top, I'm going to have 5 outside times 1, so 5. Square root 3 times square root 7, so square root 21. Over, on the bottom, I've got square root 7 times square root of 7, which is 7. Since the 21 is inside the radical and the 7 is outside the radical, there's nothing I can do to simplify that anymore, and so that is my answer. Okay, and for the last problem, 35, we've got 5 square root 2 over 4 square root 10, and so when I look at that, you might think, oh, I don't think I can do anything with that. There's actually a couple ways you can go about it, but I think the easiest thing is just to identify that there's a problem right there. And so what I'm going to do is I'm going to multiply by 1, and it's going to be the square root of 10 over square root of 10. I don't care about the square root of 2. That's not a problem. Just the square root of 10 is a problem. I don't care about the 4. That's not a problem. The only thing that's a problem, that's what I want to get rid of. So on the top, I've got 5 times square root 2 times square root 10. On the bottom, I've got 4 times square root 10 times square root 10. So on the top, I've got 5, and then square root 2 times square root of 10 is square root of 2 times 10, which is 20, but I don't want to write 20 because I have to simplify it. So 2 times 10, I can write it like that. On the bottom, I've got 4 times, and then square root 10 times square root of 10 is just 10. So what that does for me is it gives me a pair of 2's, so on the top I'll have 5 times 2 and then square root 5, and on the bottom I've got 40. Now if you recognize this, it might be more helpful actually if you leave the 4 times 10 as 4 times 10, because you guys, what is this? So what I've got is I've got 10 square root 5 over 4 times 10. Both of those 10's are outside the radical. I can cancel those. So what I have in the end is I have square root 5 over 4, and that is my final simplified answer. Now what if you didn't recognize that 10? What if you went ahead and put 40? It's fine. You would have 10 square root 5 over 40, but then looking at it, if you had a fraction of 10 over 40, you would reduce that anyway, so you would say that that's 1 over 4, so you'd have 1 square root 5 over 4. You don't need to write the 1. And so that's all. It just is a little bit easier if you can recognize things like that happening. And the more experience you have, the more you'll recognize it.